Hello, everyone. I am Raizmi Paha. In the continuation of conceptual system design phase 3 reporting, I will discuss the figure 5.4 in our textbook Information Technology Auditing, 3rd edition by James Hall. This figure was found on page 185, which is the top-down decomposition of the structured design approach. But before that, let's have a short review on the previous topics. There are two approaches to conceptual system design: the structured approach and the object-oriented approach. What is structured approach? Structured approach, it develops each new system from scratch from the top down. What is object-oriented approach? Object-oriented approach, it builds system from the bottom up through the assembly of reusable modules rather than create each system from scratch. And now, let's discuss top-down decomposition of the structured design approach. We can see from this diagram how the systems designer follows a top-down approach. The designer starts with an abstract description of the system and, through successive steps, redefines the view to produce a more detailed description. In our example, process 2.0 in the context diagram is decomposed into an intermediate level DFD or data flow diagram. Process 2.3 in the intermediate DFD is further decomposed into an elementary DFD. This decomposition could involve several levels to obtain sufficient details. Let's assume that 3 levels are sufficient in this case. The final step transforms process 2.3.3 into a structure diagram that defines the program modules that will constitute the process. The conceptual design phase should highlight the differences between critical features of competing systems rather than their similarities. Therefore, system designs at this point should be general. The designs should identify all the inputs, outputs, processes, and special features necessary to distinguish one alternative from one another. What is top-down decomposition? It is a top-down approach, also known as stepwise design and stepwise refinement, and in some cases used as a synonym of decomposition. Top-down decomposition is essentially the breaking down of a system to gain insight into its compositional subsystems in a reverse engineering fashion. Top-down decomposition, an overview of the system, is formulated specifying but not detailing in a first-level subsystem. Each subsystem is then refined in yet greater detail, sometimes in many additional subsystem levels, until the entire specification is reduced to base elements. A top-down model is often specified with the assistance of black boxes, which makes easier to manipulate. However, black boxes may fail to clarify elementary mechanisms or be detailed and realistically validate the model. Top-down approach starts with a big picture and breaks down into smaller segments. To give a clearer idea, let us look a more graphical manner. At the highest level, we had the system. The whole large programs work in conjunction with each other in order to achieve a common purpose. So, as I've mentioned, the system is made of programs or maybe a multiple programs. But here, we can see two programs making up the system. These programs are made up of multiple modules, so all the sub-elements within the programs have been joined together in order to make up this program. Each module is made up of multiple sub-programs, achieving the different control structures of each module. I hope this gives you an appreciation and understanding of the top-down decomposition of structured design approach. For more understanding, here's a video that will help you to learn better. Thank you and have a good day.
Here's a fancy one that you get in interviews sometimes. You get asked to explain what is the top-down design approach when it comes to software, apps, websites, anything like that. Well, it's really simple, believe it or not. We start at the top, and at the top we have software, app, whatever it is. We have a complete product, in other words. Once we step down another level, we can split that product into things like the graphical user interface, the business logic, which transforms data, and the data sources, which is where the data comes from. So you get the data, you transform it, and then you display it. That's basic software in all of its forms, really. You can further split those down into individual elements. So for example, the GUI will have things like button, text, and various related GUI items, and they will all be very similar throughout the app because you'll have a theme. Okay, so you can break it down into, let's say, a class of buttons that's spread throughout your app. Your business logic, you would break down into logical transformations. So let's say you need to show the date time. You might want to change your server's date time format into a human readable one, so you'd have a function for date time somewhere. You'd also have other functions to do business logic, like if this, then that. That's what IFTTT stands for. And if you search for that, there's lots of Google references to it. You might have something like a view model, which feeds the graphical user interface with the data to display. And then moving on to data sources, you'd have something like a database store, RoomDB in Android, SQLite in iOS and Windows, or Core Data in iOS, but I wouldn't touch that. I'd stick with SQLite, top tip. You'd also have things like servers that you are making calls to that provide data back to the app. So this whole picture together defines the top-down design approach. We break the software into logical elements, we break those elements into logical elements, and we keep breaking them down until all those elements fit neatly in a class. And that is the root of the name class. It is a class of objects and functions that sit logically together. So that is the top-down design approach. Now, in an interview, when they ask you that, you don't have to run them through this. You simply have to say the top-down design approach is where we break software into its most fundamental component parts so we can work on those component parts and eventually bring them back together to make software. And of course, the advantage is nothing talks cross purposes. So in programming, we never want things to talk across each other. We want them to always be separate. And it allows you to split the work up into teams. So I would be fine with data and business, but I'm not so hot on the graphical user interface. There are people better than me. So we would give that to them and say, hey, design something whizzy. I'll do all the code in the back end. So that's it. That's the top-down design approach.